Hi everyone, today's lesson will be on surds and we will be looking at what surds are, simplifying surds and expanding brackets using surds. Okay, so square root of 7 is a surd because on your calculator when you do the square root of 7 you end up with 2.645751311. I'm just going to write that down to 9 decimal places. That is a surd. So a surd is a square root that would give you a horrible decimal answer. Whereas if I do the square root of 4 on my calculator, I end up with the number 2. That's not a surd because I end up with a whole number. Now let's have a look at another example. If I do the square root of 15, I end up with 3.872983. And okay, so that is a surd because I end up with a decimal number, whereas the square root of 16 is 4. That ends up as a whole number, so that's not a surd. Okay, let's have a look at simplifying surds. We've got the square root of 24. What you need is two numbers that multiply together to make 24, with one of them being a square number. So I can think of 4 times 6. Now I know 4 is square. Now the square root of 4 is 2. And well, can I simplify square root 6 any further? So by that I mean, can you think of any two numbers that multiply together to make 6 with one of them being a square number? Now that's not possible because we've got 1 times 6, none of them are square. And then we've got 3 times 2, and that's not square. So we can't simplify that any further. So I've got 2 times square root 6. Well, we don't write the times sign in between, so we're just going to write 2 root 6. So the square root of 24, it simplified, would give me 2 root 6. Okay, that's the first example. Let's have a look at another example. The square root of 32. Okay, so again, two numbers that multiply to make 32, with one of them being a square number. So I can think of 16 times 2. I know that the square root of 16 is 4. I can't simplify square root 2 any further because there's no square number that goes into the number 2. So that's going to stay as it is. So my answer is 4 root 2. Now, there is more than one way of doing this. So don't worry about it if you had other numbers in your mind. You could have also done 4 times 8. I know that the square root of 4 is 2 times the square root of 8. However, you just have to simplify this further and there'd be an extra step for you because I can actually break square root 8 up because I've got 2 times at the start. I can find two numbers that multiply to make 8 with one of them being square. Now we've got square root of 4 times square root of 2. So 2 times, well I know that the square root of 4 becomes 2. And I can't simplify square root 2 any further because there's no square number that goes into the number 2. So that stays as it is. I've got 2 times 2 here, which is 4 root 2. And as you can see, you end up with the exact same answer. But if you don't pick the largest square number that goes into your number, then it just means that there's a few extra steps there for you to do. Whereas if you pick the largest one, it's pretty much straightforward and you get to the answer quicker. Okay, let's have a look at a few more before we get on to expanding brackets and simplifying. So third example, let's have a look at square root 50. So two numbers that multiply together to make 50, with one of them being square. So I could think of 25 times 2. 25 is square, isn't it? Because the square root of 25 is 5. And I can't can't simplify square root 2 any further because there's no square number that goes into 2. So it's just 5 root 2. Okay. Another one. Okay. So another example, let's have a look. Let's do square root 150. So think of two numbers that multiply together to make 150. Okay, I can think of 25 times 6. Square root of 25 is 5. times the square root of 6. Well, I can't simplify square root of 6 any further because there's no square number that goes into 6. So it's just going to stay as 5 root 6. Okay. Let's do one more. Let's do square root 200. Okay. I can do square root of 100 times square root of 2. Square root of 100 is 10. And I can't simplify square root 2 anymore, so it's going to stay as 10 root 2. Okay. Right, let's have a look at expanding some brackets using surds. So it's a slightly higher skill than just simplifying surds. So the first example we are going to do is square root 3 times 3 minus square root 3. Okay, square root 3 times 3, or you could say root 3 times 3 would give us 3 root 3. Subtract, well, root 3 times root 3. I'm just going to write that here so you can see what happens. You could do that at the side if you wish to do so, if it makes your life easier. Root 3 times root 3, well, you just times the numbers inside. 3 times 3 is 9. So we end up with square root of 9. But we know what the square root of 9 is. The square root of 9 is 3. So square root 3 times square root 3 is actually just 3. Okay, now we can't simplify this any further. We can't subtract the 2 because the number 3 here doesn't have a square root with it, so it can't be subtracted. I can't simplify square root 3 any further because there's no square number that goes into square root 3. Therefore, this is going to stay as 3 root 3 minus 3. Okay, let's have a look at another example. Okay, square root of 2 times 6 plus 2 root 2. Okay, so root 2 times 6 is just 6 root 2. It's just like saying x times 6. That would be 6x, wouldn't it? So exactly the same situation here. Root 2 times 6 is 6 root 2. Plus, now this is slightly tricky. We've got root 2 times 2 root 2. So I'm just going to write that down here at the side so you can see what we're doing. What you would do is you times the numbers at the front of the square roots together. Now the invisible number here is 1. We just don't write it down. So 1 times 2 would be 2. Then you times these square root numbers together. So square root of 2 times square root of 2 is square root of 4. However, here, square root of 4 is actually the number 2. So 2 times 2 is 4. So it's slightly tricky, isn't it? So plus 4. Now, I can't simplify this any further because square root of 2 can't be simplified further. And we can't add them together because that doesn't have a square root 2 with it. Therefore, the answer is just 6 root 2 plus 4. Okay, let's have a look at another example. Square root of 7 times 2 plus 3 root 7. Root 7 times 2 is 2 root 7 plus, now we need to do root 7 times 3 root 7. So just write that down at the side. So you times the numbers at the front together. Well, the invisible number there is 1. 1 times 3 is 3. And root 7 times root 7, just times the numbers together, is square root 49. But we know that the square root of 49 is 7. So 3 times 7 is 21. Okay, and that is your answer. I can't simplify that any further because square root 7, there is no square number that goes into 7, and we can't add them together because the 21 does not have a root 7 with it. Okay, let's have a look at another example. Root 2 times square root of 32 minus square root of 8. Okay, so root 2 times root 32, if I just do that here at the side, you just times the numbers together. So 2 times 32 is 64. But I know what the square root of 64 is, that's 8. Subtract. Now we need to do square root of 2 times square root of 8. Again, you just times square roots together. So I end up with square root of 16. However, I know what the square root of 16 is. It is 4. So 8 take away 4 is just 4. So my answer is 4. Okay. Let's have a look at a few more examples. Okay, fine. Let's do 3 root 2 now times 5 minus 2 root 8. Okay, so 3 root 2 times 5, I'm just going to write that at the side. You could do exactly the same. You just times the whole numbers together. So there's no surd here, is there, with the 5? So you times the whole numbers, which are 3 and 5 together, which is 15. And then it's just 15 root 2. Oops. Okay. So we've got 15 root 2. And then we've got 3 root 2 times, well, put a subtract there, times 2 root 8. Okay. So we've got 3 times 2 is 6. And then root 2 times root 8 is root 16. However, I know what the square root of 16 is. It's 4. So that's 6 times 4 is 24. And I can't really subtract them because the 24 doesn't have a square root with it, and square root of 2 you can't simplify because there's no square number that goes into 2. Okay, let's make it slightly difficult and let's do double brackets now. Okay, so the first example I'm going to give you is square root of 5 minus 3 times by square root of 5 plus 1. Okay, square root of 5 times square root of 5. If I do it at the side here. Okay, square root of 5 times square root of 5 is square root of 25, but square root of 25 is 5. Then square root of 5 times 1 is just plus square root of 5. Minus 3 times root 5 is minus 3 root 5. Remember, think of it as minus 3 times x. That would be minus 3x, wouldn't it? But this time we've got minus 3 times root 5. It would be minus 3 root 5. And then minus 3 times positive 1 is minus 3. Okay, well, I could do 5 take away 3. That's 2. And then I've got root 5 minus 3 root 5. Okay, so let's write that down here. 5 minus 3 root 5. Well, the invisible number here is 1. So if this was 1x minus 3x, what would it be? So think about that. So 1x minus 3x would be minus 2x, wouldn't it? So this would just be minus 2 root 5. Okay. And again, we can't subtract this because this doesn't have a square root 5 with it. And I can't cancel this down because square root 5, there is no square number that goes into 5. So we're just left with 2 minus 2 root 5. Okay, another example. Square root of 3 plus 2. Square root of 3 plus 4. Okay, we've got square root of 3 times square root of 3. Square root of 9. However, I know the square root of 9 is 3. Square root of 3, or root 3 times 4, is plus 4 root 3. Plus 2 times root 3 is plus 2 root 3. And then 2 times 4 is 8. Let's add these together now. I know I can add 3 and 8 together. 11. And then 4 root 3, add 2 root 3, we can add together because they've got the same square root. That square root 3 and that square root 3. So it's like 4x add 2x, which would be 6x, but this is just 6 root 3. And there we are. We can't simplify this further because the 11 does not have a square root 3 with it. And we can't cancel root 3 down any further because there's no square number that goes into it. Okay, let's have a look at another example. We've got 2 plus root 7 times 2 minus root 7. Okay, 2 times 2, 4. 2 times minus root 7 is minus 2 root 7. Root 7 times positive 2 is positive plus 2 root 7. And root 7, it's just a minus there, times root 7, as we know, will just be 7 because that's square root of 49, but the square root of 49 is 7. I can do 4 take away 7, which is the two whole numbers, so I can subtract them, can't I? So 4 take 7 is minus 3. And then I know that both of these have a square root 7 with them, so I can do minus 2 root 7 plus another 2 root 7, or that cancel each other out, so that's nothing. So I'm just left with minus 3. Okay. Let's have a look at another example. Okay, let's have a look at 3 minus 2 root 7 times by 4 plus 3 root 7. So we're going to do 3 times 4, which is 12. 3 times 3 root 7. So you just times the whole numbers together. So it's 3 times 3 is 9. Just root 7, because the number 3 doesn't have a root with it, so you can't really times that with anything. Okay, so that becomes plus 9 root 7. And then we've got minus 2 root 7 times 4. So again, just times the whole numbers together. It's minus 8 root 7. Because that doesn't have a root 7 with it, you can't really do anything. Can't really times it by anything. That's what I meant. We've got minus 2 root 7 times by 3 root 7. So again, times the whole numbers together. Minus 2 times 3 is minus 6. Well, root 7 times root 7 we know is root 49, which is just 7. So minus 6 times 7 becomes minus 42. So again, what you can do is, you can do 12, subtract 42. That becomes minus 30. And then we've got 9 root 7, take away 8 root 7, which is just 1 root 7. So just plus root 7. Okay. Let's have a look at another example. Let's have a look at 2 plus square root of 5 all squared. Okay. So this means squared. So squared obviously means you times it by itself. So that means 2 plus square root of 5 times 2 plus square root of 5. Well, 2 times 2 is 4. Square root of 2 times square root of 5, or 2 times root 5 is plus 2 root 5. And then root 5 times 2, again, is plus 2 root 5. And then root 5 times root 5 will just be 5, because that becomes square root of 25, but square root of 25 is 5. Add the numbers up on the outside. 4 odd 5 is 9. Then 2 root 5 plus another 2 root 5 is 4 root 5. Can't simplify this further, so we leave it as it is. Okay, well, let's do another example. Let's do 1 subtract root 2 all squared. So again, that's double brackets because it's squared. Okay. 1 times 1 is 1. 1 minus root 2 is minus root 2. Minus root 2 times 1 is minus root 2 again. And then minus root 2 times minus root 2. Well, we know that's going to be a plus because two negatives times together to make a positive. And then root 2 times root 2 is just going to be 2 because that becomes root 4. But root 4 is 2. Add the numbers together. That becomes 3. And minus root 2 minus another root 2 becomes minus 2 root 2. Again, you can't simplify this any further, so we leave it as it is. Okay, so we've simplified some single brackets, simplified some double brackets, and we've looked at how to simplify some surds. In today's lesson, you'll be asked to do this at GCSE level. It is quite a tricky skill to do, but have a go at some of the questions that we've done here together and see how you get on. I hope this lesson was useful. Thank you for watching.